Hello everyone. Today we are going to discuss about chromatography, and it's an important chapter in the examination point of view. If you are looking at the previous question papers of the coursework examination, we can see that there are so many questions from chromatography in part A and also in part B. Let's come to what is chromatography. So chromatography basically is a laboratory technique. Normally we used to do this technique for the separation and followed by identification and quantification. So here in chromatography we know there are two phases. One is a stationary phase and another one is a mobile phase. So stationary phase, this means it doesn't move. Normally we have an adsorbed surface like silica gel or alumina or paper, and we have an eluted kind of mobile phase. Maybe it's a liquid or a gas. So this is how we have two components in chromatography, and based on the interactions of these two phases like mobile phase and stationary phase, the separation occurs and we get the compound from the mixture. So here chromatography works on the principle of differential distribution of component between two phases, as I mentioned. Normally the stationary phase, it can be either solid or liquid. So when it interacts with the compounds, that normally the compounds we need from the mixture is adsorbed on that, or maybe there are different kind of separation techniques based on the interaction. We will see it later. Then we got a mobile phase. It can be either a carrier gas or a liquid. So this is the phase which carries the compounds through the stationary phase, and the process is known as elution. Elution is the process of separating and purifying compounds from mixture by passing a solvent or mobile phase through a stationary phase, such as a chromatographic column. So it works on the principle of differential affinity between compounds and stationary phase. So compound with weaker affinity are eluted first and stronger affinity are eluted the last. So that's the principle of chromatography. So here we have a university question which asks us to explain the terms like stationary phase, mobile phase and eluent, and it is asked on the basis of column chromatography and TLC, and this is the second B part. I mean actually it's a B part of a question appeared in part A. So there were three questions regarding the same and we will discuss it later. So you can explain what is stationary phase, and normally in column chromatography how alumina and silica are acting as a stationary phase, and what is mobile phase. You can explain solvents like hexane, dope, methanol like ethyl acetate and methanol with their polarity, and how the process of elution occurs and how mobile phase is acting as eluent. Based on different principle, maybe or maybe the type of stationary phase or mobile phase or even the dimension, we can separate these chromatographic techniques. The first one is based on principle. So we can classify it into adsorption, partition, site substitution, affinity and ion exchange chromatographies. So during adsorption, we can have a solid phase, and then we can use a liquid or a gas um, as a moving phase. For example, it's like normal column we use, like silica gel column we use. Then partition chromatography, we can use the techniques of partition. So here we use either liquid partition thing or liquid gas thing. So in size distribution is based on the size of the analyte we are separating it, and affinity is based on the principle of affinity. So normally it happens between antigen and antibody and all. Then we have ion exchange chromatography. So here it can be cation or an anion. So we separate according to the charge and charge distribution of the analyte. Then based on the stationary phase, it can be either normal or a reverse phase chromatography. As you know, in normal phase, what we are taking is like we are taking a non-polar or a mobile phase, and in reverse phase, it's just opposite. So here we go for a polar solvent or polar mobile phase, and we are taking a non-polar stationary phase. And even if you are considering the mobile phase or the moving phase, then we can use liquid as our mobile phase. Then it will be kind of liquid chromatography. Then we can have a gas chromatography. We can here we will be using a solid or a liquid, and then gas is a mobile phase. And even in liquid chromatography also there can be a solid liquid or liquid liquid. Normally you may doubt how this liquid liquid thing happens. So whenever we are taking a paper, so though the stationary phase is a paper, it's first soaked in a liquid, or when we place it in a liquid, first when it passes through the liquid. So what happens is here, even the liquid itself is acting as a stationary phase, though liquid absorbed on the solvent is acting as a stationary force. So here we can have liquid liquid or solid liquid chromatography. And some cases we are using supercritical fluids such as CO2, supercritical CO2 as a moving phase, mobile phase. And there is the third classification, and based on the dimension we know we can have TLCs or paper chromatographies. This comes under 2D, two dimension. And we can have columns. So that's a three-dimensional technique. Hope you got that. And moving to the next. So we have some previous questions here. The first one is mention the physical process involved in TLC and column chromatography. You can write about adsorption. On which parameter separation and identification of various components in a mixture of organic compounds occur. You can write about polarity, molecular weight, and charge, etc. Write two differences between TLC and CC. You can mention about what is TLC and what is CC. One is two-dimensional and the three-dimensional, and one is used mainly for preliminary examination and one is for separation. And how size of silica mesh can influence the separation. You can mention finer silica mesh used for better resolution, and how larger silica mesh is easy for elution, or it determines the flow rate, etc. And we can discuss it clearly in the video of column chromatography and the chromatographic technique for the separation of amino acids. You can mention, since it is charged, then it's we can use ion exchange chromatography. And about the molecular weight, you can use side substitution chromatography, and even we can try reverse phase chromatography also. Explain the principle of size exclusion chromatography. You can write about how molecular weight determines, or how the size and shape and molecular weight determines the flow rate or the elution conditions of size exclusion chromatography. Slide, we can have adsorption chromatography. Here the principle is adsorption. So it's a reversible adsorption where compounds interact with the stationary phase through weak intermolecular forces such as van der Waals force and hydrogen bonding. So first here adsorption takes place, compound interact with the stationary phase, compound gets adsorbed on the stationary phase, then desorption. Then it is gradually, when we are increasing the polarity of the solvent, it gradually releases from the stationary phase. Then based on that we can have a separation. So separation basically takes place because of this adsorption and desorption rates. So examples are gas solid chromatography and liquid solid chromatography and thin layer chromatography. Next we have partition chromatography, our second classification. It is based on the principle that of partitioning between two immiscible phases such as a stationary phase and a mobile phase. Here also it depends on the principle of equilibrium distribution, where the compound distribute between two phases based on their relative affinities. So here the first concept is, or the first mechanism is partitioning, where the compound distribute between stationary phase and mobile phase, and then separation. So liquid liquid partition or gas liquid partition, etc. can be considered here. Here also there are paper chromatography, as I mentioned. Here even paper is a solid thing. When liquid gets absorbed, this acts as a kind of liquid chromatography. Then thin layer chromatography. So this is another university question which asks us to distinguish between partition chromatography and adsorption chromatography. Here you can give the principle saying like one is partition and another is adsorption, and what is bulk phenomena and what is surface phenomena, and then you can mention the types, examples, etc. So it was asked for 2 marks, so you can give 4 points for 2 marks. So next we have ion exchange chromatography. As the name indicates, it exchanges ion or polar compounds. So it is based on the principle of electrostatic interaction is working out. And as you know, there are two types. Either it can be an anionic exchange chromatography or cation exchange chromatography. So for cation exchange chromatography, we are using it to separate cations. So here the stationary phase is negatively charged. So or it should contain anions, or it can be anionic resin. So the charge of the chromatography, or the charge of the analyte we have to separate, should be the opposite of charge of the resin. So for cation exchange chromatography, we use anion resin, or for anion exchange we use cation resins. Otherwise, those electrostatic interaction would not work. So here ions of the mobile phase interacts with ion attached to stationary phase. So if you are taking anions in the mobile phase, cation should be in the stationary phase. That's the thing you have to remember here. So first mechanism is ion exchange. So these ions in the stationary phase will be having a counter. For example, if you are taking cation resin, then we will be having an counter ion like anions in the attached to that, but that will be washed away by those ions in the mobile phase, and they will replace it. For example, if you are having Na plus ions in the resin which is preloaded, so when we are using a mobile phase, it will be washed away and will be substituted by other cation. So in this case, that is called ion exchange. So in next step, due to electrostatic attraction, what will happen? These ions will be bind to the stationary phase, and then depends on the charge and all, and will gradually release. So for cation exchange resin, the resin cation exchange chromatography, the resin should have a negative charge. Normally zeolite have oxygen is present, will be used for that purpose. And for anion exchange, the resin should be in positive charge. For that purpose, we use quaternary ammonium salts in the resin in the stationary phase. And then we have size exclusion chromatography. Here the molecules are separate based on their size, shape and molecular weight. So here the smaller molecule will enter the pores of the stationary phase, because stationary phase will be having so many pores inside. So they will get smaller molecules will get entrapped within these pores, and bigger molecules will be excluded. They will be eluted so fast. So that's the principle of size exclusion chromatography. It's also known as gel chromatography, and there are two types. One is gel permeation chromatography and gel filtration chromatography. We will see the details later. So here the mechanism is first size exclusion. So molecule will be separated based on their size and shape. Then pore penetration, smaller molecules will get in the pores and larger molecules cannot because of size. So the larger molecule will be eluted first along with the mobile phase, and the smaller molecule will come last. So that's the concept of size exclusion or gel chromatography. So then we have affinity chromatography. Here the biomolecules are separated based on specific interaction between analyte and immobilized ligand. Basically, considers the biological recognition mechanism. As you know, how the way enzymes and substrate reacts, and antibody and antigen reacts. So there's a molecular recognition. So that's the concept behind this affinity chromatography. So it can be antigen antibody or enzyme substrate or receptor ligand interaction. So basically, first binding takes place, then separation takes place, then elution takes place. So it can be biospecific affinity chromatography, or immunoaffinity chromatography, or lectin affinity chromatography, or receptor affinity chromatography. Normal phase chromatography. So in normal phase chromatography, what happens is like here our solid phase is normally polar. So it basically works on the principle of adsorption, where polar component interact with polar stationary phase, while non-polar compounds pass along with mobile phase, which are normally in a non-polar nature. So when it occurs in reverse phase chromatography, the principle is just reversed. So here what happens is like our stationary phase will be highly non-polar in nature and mobile phase will be highly polar. So what happens is that here polar compounds will be eluted first and non-polar compound will be interacting with stationary phase. That's the basic understanding of chromatography, and we will see each type of chromatography techniques in detail in the next slides. Thank you.